Hello dear student, welcome to new session of Newton's laws of motion. In this session we'll discuss about equilibrium of forces. So write down next heading, it is equilibrium of forces. So see my dear student, this word equilibrium is familiar with you in chemistry as well. Sometime we says that now the reaction is in equilibrium. So if we'll say reaction is in equilibrium, it implies no further change can take place in the reaction. Similarly, when we are talking about equilibrium of forces, this word equilibrium means F net. My dear student, there is two things. One is force and another is net force. Both the things are very different to each other. Let's suppose a particle is placed in a floor having mass m. Now see my dear student, if mass is m, then its weight is mg and it acts vertically downward. And this block is in contact with the floor, so there is a force is present, that is normal reaction force. Now see my dear student, this is our vertical axis and this is our horizontal axis. So along vertical axis we have two forces, one is normal reaction force and another is weight of the body. Both the forces are opposite to each other, opposite in direction to each other. Now just imagine, it is not possible by block to come down or go up. So we'll say forces are there in vertical axis, but its effect is zero. See, the effect of force is the body come to be in motion. So if you will see my dear student, there is a force along positive y-axis and there is a force along negative y-axis. But due to this force, the body cannot move upward or body cannot comes down. So we'll say the net force along vertical axis is zero. Net force along vertical axis is zero. Force is there, forces is there along vertical axis, but its effect is zero. So we'll say net force is there. So net force is equals to, my dear student, zero. So moving forward, when we are talking about equilibrium of forces means net force acting on body must be zero. Net force acting on body must be zero. Now we all aware with a relation which is F net is equals to ma net. This is nothing but Newton's laws of motion. This formula will be studied by you in class 9th as well, my dear student. So F net is equals to ma net. This is the formula of in Newton's, according to Newton's second law of motion, F net is equals to ma net. So if I am saying that the body is in equilibrium, or we can say equilibrium of forces, it means net force is equals to zero. Now see, if net force is equals to zero, then it is but obvious that net acceleration is also becomes equals to, my dear student, zero. So remember, the technical meaning of equilibrium of forces means net acceleration is zero. So write down, please write down on your notebook, equilibrium of forces means equilibrium of forces means net acceleration acting on the body, net acceleration acting on the body is zero. Net acceleration acting on a body is zero. Or we can say equilibrium of forces implies that forces are acting on the body, but its effect is 0. So remember, this is the two basic meaning of equilibrium of forces. Equilibrium of forces is the condition in which net force acting on the body is 0, and if we are saying net force acting on a body is 0, it implies forces are acting on the body. It never means that forces is not acting on body. Forces is acting on body, but its effect is 0, and its effect is 0 means forces are acting opposite in direction, equal in magnitude, my dear student. So remember, equilibrium of forces means net force is equals to 0, and if any body acquire net force is equals to 0, it implies, it is but obvious that net acceleration is also equals to, my dear student, 0. So equilibrium of forces means net acceleration acting on the body is 0, or we can say equilibrium of forces implies that forces are acting on body but its effect is 0. It means forces are equal in magnitude and opposite by direction. So if forces are equal in magnitude and opposite by direction, then they cancel out their effect, that is body remains at rest unless it acquire forces. So moving forward, now we know that acceleration is nothing but change in velocity with respect to time. If a body carries some velocity, and that velocity is changing, my dear student, then we will say body is accelerating. Now see, at what condition we will say that body is in equilibrium. So my dear student, as we know now that equilibrium of forces means net acceleration is equals to 0, and we know that acceleration is nothing but change in velocity with respect to time. So if I am saying net acceleration is 0, it will be achieved under two different conditions. First, if the body is at rest. See my dear student, if body is at rest, then it is but obvious its velocity is equals to 0. And if velocity of the body is equals to 0, it implies that acceleration is also becomes equals to 0. So we'll say if the body is at rest, then the body is in equilibrium, or we can say if body is at rest, then net acceleration is 0. Hence we'll say the forces which is acting on body is in equilibrium condition, that is forces are acting but their magnitude are equal and opposite in direction. Moving forward, second condition when the body is in equilibrium of forces, if the body is moving with constant velocity, my dear student, constant velocity. So in this situation, body is in motion but its velocity is constant. So if velocity is constant, it implies velocity is not changing, and if velocity is not changing, then it is but obvious the acceleration of body is equals to 0. So in this board you will see that equilibrium of forces means net force is equals to 0, or we can say if net force is equals to 0, it implies net acceleration is also equals to 0. So net acceleration is equals to 0. Moving forward, my dear student, there are two different conditions in which we'll say body is in equilibrium or the forces which is acting on body is in equilibrium. First thing, if body is at rest. So if body is at rest, then its velocity is 0, and if velocity is 0, we know that acceleration is equals to change in velocity with respect to time. So if velocity is 0, my dear student, then it is but obvious that acceleration is also equals to 0. Second point related to equilibrium of forces is if the body is moving with constant velocity, then also we'll say the body is in equilibrium, because if velocity is constant, it implies acceleration is equals to 0, because acceleration is achieved by body when velocity is changing. So if body is moving with constant velocity, it implies the velocity is not changing, hence acceleration is equals to 0. So if we'll conclude the topic, which is equilibrium of forces, it implies forces are acting on body but equal in magnitude and opposite in direction. So write down in form of note, if the body is in equilibrium, write down in form of note, if the body is in equilibrium, if the body is in equilibrium, it implies forces is acting on body, it implies forces is acting on body but equal in magnitude, forces is acting on body but equal in magnitude and opposite in direction. Equilibrium of forces means forces is acting on body, forces is acting on body but equal in magnitude and opposite in direction. Equal in magnitude and opposite in direction. It implies the net force acting on body, 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 the net force acting on body is 0. The net force acting on body is 0. The net force acting on body is 0. So I hope you all understand what actually equilibrium is. So remember, equilibrium means the forces is acting on body but equal in magnitude and opposite in direction. Its effect is nothing, its effect is equals to 0. Technical meaning of equilibrium of forces means net acceleration is equals to 0. We know that acceleration is nothing but change in velocity with respect to time. So if velocity is changing with respect to time, then the body acquire acceleration. So if the body is in equilibrium, it implies net acceleration is equals to 0, which will be achieved in two different conditions. First condition, if the body is at rest. So see, if the body is at rest, then it is but obvious that its velocity is 0. And if velocity is 0, then acceleration is also equals to 0. Similarly, if the body is moving, but moving with constant velocity, my dear student. So if body is moving with constant velocity, it implies velocity is not changing. And if velocity is not changing, then how acceleration is achieved by body? So no acceleration is present on body, even the body is in motion. Still we will say that net acceleration is 0, that is body is in equilibrium. So I hope you all understand what actually equilibrium is. Now we'll solve some numerical so that it will make more comfortable with the topic called equilibrium of forces. Write down first question. If the system is in equilibrium, write down first question. If the system is in equilibrium, if the system is in equilibrium, if the system is in equilibrium, then find the value of tension. Find the value of tension present on string. If the system is in equilibrium, then find the value of tension present on string. This is very easy question, my dear student. This is just to more comfortable you, will make comfortable you. See, there is a string and a block is there. Let's suppose the mass of block is 2 kg and tension T is present on string. So they are saying if the system is in equilibrium, equilibrium means net force acting on body is 0. Meaning of net force is opposite forces are equal in magnitude and opposite in direction. So let's make the free body diagram of this 2 kg. Vertically downward mg, so 2 into 10 it is 20, and in upward direction a force is present in string, we know that the force which is present on string is tension, which is always a pulling force. So in upward direction, tension must be present. Now see, there is a force in upward direction, there is a force in downward direction. Both the forces are in vertical direction. So see, they are saying that system is in equilibrium. System is in equilibrium means opposite forces are equal in magnitude. So T must be equal to mg. So if T is equals to mg, then the value of T is 20 and tension is a force, its SI unit is Newton. It's as simple as this. Moving forward, my dear student, write down again next question. If the system is in equilibrium, if the system is in equilibrium, if the system is in equilibrium, then find the value of, if the system is in equilibrium, then find the value of T1 and T2. Find the value of T1 and T2. If the system is in equilibrium, then find the value of T1 and T2. So we have to find the value of T1 and T2 in this question, my dear student. So see, the system is in equilibrium. So if the system is in equilibrium, it implies forces are equal in magnitude, opposite in direction. So let's make the free body diagram, and I already tell you that always remember one thing, if multiple blocks are there, then start making free body diagram from downward. So let's make the FBD of 2 kg. Here it is 2 kg, vertically downward mg, so it will be 2 into 10 because the value of g we will consider is 10, so it is 20. Now see, there is a string in which tension is present, that value of tension is T1, and we know that tension is a kind of force which is always away from body as it is a pulling force. So let's make the value of T1, so direction of T1 is upside. Now see, in question they are saying the system is in equilibrium. So if system is in equilibrium, then forces are equal in magnitude, opposite in direction. So T1 is in upward direction, mg is in downward direction, and the system is in equilibrium. It implies both forces must be equal. So I write T1 is equals to mg. So T1 is equals to 20 Newton. Now moving forward, my dear student, we'll make FBD of another 2 kg block. So let's make the FBD of 2 kg block. So if we'll see, mass is m, vertically downward mg, so 2 into 10, it is nothing but 20 Newton. Now see, this 2 kg block is connected with two different strings having tension T1 and T2. As we know, tension is a pulling force. So make the direction of tension. So T2 is pulling force, so T2 must be in upward direction. T1 is again pulling force, so T1 must be in downward direction. So I'll make T1. Now see, the system is in equilibrium. So if the system is in equilibrium, it implies opposite forces are equal in magnitude. Forces are equal in magnitude and opposite in direction. If you are seeing, two forces are in downward direction, one force is in upward direction. So T2 must be equal to opposite force, that is T1 plus mg. So I'll write T2 is equals to the value of T1 already we'll get, it is 20. So 20 plus mg is 20. So T2 is equals to, my dear student, 40 Newton. This is how we'll solve the numericals related to equilibrium of forces. Moving forward, write down next question, my dear student. If the system is in equilibrium, I hope you all are enjoying, you all try to make FBD by your own so that you will come more comfortable in this topic. So write down next question. If the system is in equilibrium, if the system is in equilibrium, if the system is in equilibrium, then if the system is in equilibrium, then find the value of, if the system is in equilibrium, then find the value of T1, find the value of T1, T2 and T3. T1, T2 and T3. So we have a system, my dear students. See, 3 blocks are there, 3 kg, 1 kg and 2 kg. In this string, T1 is there, T2 is there and T3 is there. So the question is, if the system is in equilibrium, then find the value of T1, T2 and T3. We have to find the value of T1, T2 and T3 if our system is in equilibrium. So my dear student, as this is a multiple block system, start making FBD from denominator below part, or we can say lower part. So let's make the FBD of 3 kg. So vertically downward it is mg, because mass is there, then weight is acting on a body which always acts vertically downward. So mg, mass is 3, g is 10, so it is 30. Now see, one rope, or we can say string, is connected with 3 kg block. So there must be a tension which is always a pulling force. So away it is T1. Now the system is in equilibrium. So if system is in equilibrium, then forces are equal in magnitude, opposite in direction. So T1 is in upward side, mg is in downward side. System is in equilibrium implies T1 must be equal to mg. So T1 must be equal to mg. So T1 must be equals to 30 Newton. We'll get the first value. Moving forward, make the FBD of 1 kg block, my dear student. So this is our 1 kg block. We know that vertically downward mg. Now see, this 1 kg block is connected with two different strings having tension T1 and T2. As we all know that tension is a kind of pulling force. So T1 must be in downward direction because it always a pulling force. T2 must be in upward direction because tension is always a pulling force and it always made away from the body. Remember, this is very important point, my dear student, that tension is always acts away from the body. You have to make tension always away from the body. So moving forward, as the system is in equilibrium, so it implies that forces are equal in magnitude, opposite in direction. So if you see here, 1 kg block carried two forces in downward direction and one force in upward direction. So it implies upward force must be equal to downward force. So upward force is T2 and downward force is T1. So T2 is equals to mg. It means 10 because mass is 1 and g is 10, so it will be 10. So 10 plus T1. So T2 must be equal to 10 plus the value of T1 is 30 Newton. So T2 must be equals to 40 Newton. Moving forward, my dear student, now we have to find the value of T3. So let's make the free body diagram of 2 kg block. Here comes 2 kg block. Vertically downward, we know about a force called weight of the body. It always acts vertically downward. So if mass is 2, g is 10, so 2 into 10, it is equals to 20 Newton. Moving forward, this 2 kg block is connected with two different strings, my dear student, and we know that in string tension is present and tension is always a pulling force. So away from the body T3 and away from the body T2. Now see, the system is in equilibrium. So if system is in equilibrium, it implies forces are equal in magnitude, opposite in direction. So in upward direction, T3 is there, and in downward direction, two forces is present. One is mg and second is T2. So we'll write T3 is equals to T2 plus mg. So T3 is equals to T2. It is, the value of T2 is 40 Newton. So 40 plus 20, so T3 is equals to 60 Newton. So here comes the value of T2 40 Newton, value of T3 60 Newton, and value of T1 it is 30 Newton. So I hope you all understand how to solve the problem related to equilibrium of forces. Moving forward, my dear student, write down next topic, next question. If the system is in equilibrium, write down, if the system is in equilibrium, then find the value of tension. If the system is in equilibrium, then find the value of tension. Find the value of tension present. Find the value of tension present on the string. On the string. So see, my dear student, let's suppose we have a system like this. A mass is there, 2 kg, and two strings is there. One carry tension T1, other string carry tension T2. Let's suppose this T2 string is making angle 30 degree with this axis. So they are saying if the system is in equilibrium, then find the value of T1 and T2, my dear student. So try to make this question by your own. If the system is in equilibrium, they are saying that find the value of tension in the string. That is, you have to find the value of T1 and T2. So try to find, my dear student, the value of T1 and T2. See. First of all, we have to make the free body diagram. So vertically downward, it is mg. Now see, my dear student, there is a string in which tension is present and the value of tension is T1. We know that tension is always a pulling force which made away from the body. So we'll make the tension T1 away from the body. Similarly, tension T2 away from the body. Now if we'll see, my dear student, the system is in equilibrium. So T1 is in this direction. So there must be a force in this direction which will counter T1. Then only the system is in equilibrium. Similarly, if one force is in vertically downward and system is in equilibrium, it implies this mg must be countered by a force equal in magnitude but opposite in direction. So if mg is vertically downward, then there must be one force in vertically upward. Similarly, if T1 is in this direction and system is in equilibrium, then there must be a force must present in this direction. Then only the system is in equilibrium. So let's say this is 30 degree. So this is also becomes equals to 30 degree. Now if you'll see, tension is a kind of force and we know that force is a vector quantity. And we are now cover a long journey with vector. So if any vector quantity makes some angle, we have to split its component. My dear student, we all know any vector quantity carry two different components. One is cos, other is sine. The cos component must be along that axis from where angle is formed by the vector. So if you will see, the angle is formed by this line. So along this line, the T2 has T2 cos 30 degree and in this direction T2 sin 30 degree. Now my dear student, in question they are saying the system is in equilibrium. So if system is in equilibrium, it implies opposite forces are equal in magnitude, opposite in direction. So T2 cos 30 is in upward side and mg is downward side. So we'll write T2 cos 30 must be equal to mg. So T2 cos 30 must be equal to mg means 2 into 10. So T2 cos 30 must be equal to 20. So T2 must be equal to 20 by cos 30. Similarly, T1 must be equal to T2 sin 30 because the system is in, my dear student, equilibrium. So if you wish to find the value of cos 30, put the value of cos 30, it is root 3 by 2. So what we'll get? T2 is equals to 40 by root 3 Newton. This is the value of T2. Moving forward, my dear student, equalize both the forces because the system is in equilibrium, and what equilibrium says, forces must be equal in magnitude and opposite in direction. So T1 must be equal to T2 sin 30. So write down T1 must be equal to T2 sin 30 and T1 is equals to, we'll get the value of T2. So value of T2 is nothing but 40 by root 3, and you must know the value of sin 30. The value of sin 30 is nothing but 1 by 2. So 2 2s are 4. So T1 is equals to 20 by root 3 Newton. This is the value of T1, my dear student, and this is the value of T2. I hope you all are enjoying this question. These questions are very easy to solve. Moving forward, my dear student, write down next question. If the system is in equilibrium, then find the value of, if the system is in equilibrium, then find the value of T1, T2 and T3. If the system is in equilibrium, then find the value of T1, T2 and T3. If the system is in equilibrium, then find the value of T1, T2 and T3. Find the value of T1, T2 and T3. Let's suppose we have a system, my dear student, of two blocks having connected with three different strings. Let's suppose the mass of block is 2 kg and mass of this block, let's suppose it is 1 kg. So in question they are saying the system is in equilibrium, find the value of T1, T2 and T3. I'll give you 1 minute time, my dear student. Pause the video and try to solve the question by your own. Please try to make fast. Try to solve this question fast, my dear student. So if we'll solve this question, start from bottom. It is 2 kg block. So 2 kg means vertically downward mg. It is nothing but 2 into 10, so it is equals to 20 Newton. Now see, my dear student, this 2 kg block is connected with a string having tension T1, and we know that tension is a kind of pulling force, so it must be present away from the body. So T1 is away from the body. Now if the system is in equilibrium, it implies opposite forces must be equal to each other. So T1 must be equal to mg. So T1 must be equal to mg. So T1 must be equals to 20 Newton. This is the value of, my dear student, T1. Moving forward, let's try to solve the value of T2, T3. So let's make the FBD of this 1 kg block. So this is 1 kg block and a force is there, a string is there in which tension T3 is present. And we know that tension is nothing but pulling force. So if this angle is 30, then this angle also becomes equals to 30 degree. So this angle is also 30 degree. Now see, mg must act vertically downward. Similarly, my dear student, this T1 is also connected with this block. So there must be a force T1 which is always away from the body because tension is pulling force. So T1, and in this direction it is T2. Now we will imply the property of vector as the vector quantity is making some angle 30 degree with the y-axis. So break its component. So for any vector we have two different components. One is cos, another is sine. So with this line, this 30 degree is made. So the cos component must be along this direction. It is T3 cos 30, and is in this direction it is T3 sine 30. Now we know that opposite forces must be equal to each other. So in upward direction it is T3 cos 30, and in downward direction two forces there. One is mg, it is 1 into 10, so it is equals to 10 Newton, and T1, the value of T1 is 20. So we have to equalize the force as the system is in equilibrium. So upward force, it is T3 cos 30. So T3 cos 30, it is equals to T1 plus mg. So T3 cos 30 is equals to T1 is 20 and mg is 10. So T3 is equals to 30 by cos 30, and we know that cos 30 is nothing but root 3 by 2. So 30 into root 3 by 2. So T3 becomes equals to 60 by root 3 Newton, my dear student. We'll get the value of T3. Moving forward, in this direction there is a force called T2. In this direction there is a force called T3 sine 30. So as the system is in equilibrium, it implies opposite forces must be equal to each other. So we'll write T2 must be equal to T3 sine 30. So I'll write T2 must be equals to T3 sine 30. So T2 is equals to, value of T3 is 60 by root 3 and sine 30 is nothing but half. So 2 3s are 6, 30. So T2 becomes equals to 30 by root 3 Newton. So here the value of T1 is 20 Newton. We'll get the value of T2, it is 30 by root 3 Newton. We'll get the value of T3, it is 60 by root 3 Newton. So I hope you all understanding these questions. Moving forward, my dear student, write down another question. If the system is in equilibrium, write down next question. If the system is in equilibrium, if the system is in equilibrium, then find the value of tension. If the system is in equilibrium, if the system is in equilibrium, then find the value of, if the system is in equilibrium, then find the value of tension in the string, find the value of tension in the string and applied force, tension in the string and applied force if the mass of body, if the mass of body is of 800 gram, if the mass of body is of 800 gram, if the mass of body is of 800 gram. Now see my dear student, the question is like this. Let's suppose there is a string with which mass is connected. This is of 800 grams. There is a force in this direction. There is a tension in the string T, and this angle is, let's suppose, 30 degree. So they are saying find the value of T and find the value of applied force which is acting on this mass if the system is in equilibrium. So we know that if the system is in equilibrium, it implies forces are equal in magnitude and opposite in direction. So moving forward, let's make the free body diagram first, my dear student. As we know that this is a tension, and tension is always present on string, and tension is a pulling force which always made away from the body. So in this direction tension is there. This angle is 30, so this angle must be 30 degree. Now we see this is y axis, this is x axis. Tension is not present even on x, on or y. It is on between and making angle 30 degree. So we have to split its component because tension is a force and force is a vector quantity. If any vector quantity is making angle, then we have to split its component, my dear student. So let's make its component. So any vector carry two components. Along this direction cos component is present because with this line angle is formed. So along that line where angle is formed, we have to take cos 30, and is this direction, it is t sin 30. So the system is in equilibrium and vertically downward it is mg. Now see, the mass is in, my dear student, grams. So if mass is in gram, then 800 divided by 1000, it is in kg. So see, my dear student, the system is in equilibrium, and if the system is in equilibrium, it implies opposite forces must be equal. So t cos theta 30 is in upward direction and mg is in downward direction. So what it implies? It implies both the forces must be equal. Similarly, F is in this direction and t sin 30 is in this direction. System is in equilibrium, it implies opposite forces are equal. So we'll write t cos 30 must be equal to mg and F must be equal to t sin 30. So moving forward, my dear student, as we know about mass, so let's make the value of T. So T is equals to mg by cos 30. So T is equals to mg means 800 divided by 1000, g is 10, and cos 30, it is root 3 by 2. So 10 10 cancel, 20 20 cancel. 8 2 is 16 by root 3 Newton. This is the value of T, my dear student, 16 by root 3 Newton, because 800 is converted into kg, so it will be 800 divided by cos 30 is root 3 by 2. So my dear student, the value of T is 16 by root 3 Newton. Now we'll put this T in this equation. So F is equals to T sin 30. So F is equals to value of T is 16 by root 3 into sin 30 is nothing but half. So 2 8 is 16. So it will be 8 by root 3 Newton. So the value of F is 8 by root 3 Newton and the value of tension is 16 by root 3 Newton. So I hope you all understand what actually equilibrium is and how we'll solve the numericals related to concept of equilibrium. Remember, equilibrium is nothing but net force is equals to 0. In equilibrium, remember my dear student, forces are equal in magnitude and opposite in direction. This concept is, bridge, or we can say key concept of equilibrium solutions, or we can say equilibrium questions, equilibrium problems. Remember, equilibrium of forces means net force is acting on body is equals to 0. Technical meaning of equilibrium is net acceleration is equals to 0. So I hope you all understand the concept of numerical. So moving forward, my dear student, write down next topic. It is Newton's laws of motion. Newton's laws of motion. So Newton can give 3 different laws of motion, my dear student. First law is always considered to be first law. Second law is considered to be second law. And third law is considered to be third law. Remember this thing. Second law cannot consider to be first law, or first law cannot consider to be second law. There is a sequence. First law must be first law, second law must be second law, and third law must be third law. So Newton's laws of motion. Newton's laws of motion. So dear student, Newton can give 3 different laws. 3 different laws related to motion. That was first law of motion, second law of motion, second law of motion, and third law of motion. Third law of motion. So Newton can give 3 different laws, my dear student. First law of motion, second law of motion, and third law of motion. First law is considered to be first law, second law is considered to be second law, and third law is considered to be, dear student, third law. We cannot replace third law by first law. We cannot replace second law by third law. There is a sequence. That sequence is followed. First law is first law, second law must be second law, and third law must be third law. So moving forward, we are discussing now what actually first law of motion is, what actually second law of motion is, and what actually third law of motion is. So write down very first topic, Newton's first law of motion. Newton's first law of motion. So my dear student, first, before coming of first law, we don't know about mass. First law can give the information about mass. Remember this thing. First law can gives information about mass. So write down first point in first law of motion. Write down first point. First law of motion. First law of motion gives us information about the mass. First law of motion can gives us information about the mass. What actually mass is. So remember one more thing, my dear student. Mass is also said to be inertia. Mass is also said to be inertia. Remember, instead of mass we can say inertia. So first law is also called law of inertia, because with first law we will study about mass. After considering first law, we'll know what actually mass is. So remember one more thing, my dear student. Mass is also called inertia, and first law is also called law of inertia. First law is also called law of inertia, my dear student. Remember this thing. First law is also called law of inertia, and meaning of inertia is nothing but mass. Actually, technically we'll say inertia is also said to be mass. So moving forward, first law is considered to be, my dear student, law of inertia. We'll said first law as law of inertia. Inertia is nothing but mass. With the help of first law, we'll understand what actually mass is. Now see, law of inertia is classified into 3 types. Law of inertia is classified into, dear student, 3 types. First is inertia at rest. Second is inertia of motion. Inertia of motion, first is inertia of rest, second is inertia of motion, and third is inertia of direction. Inertia of direction, inertia of direction, inertia of rest, and inertia of motion. Remember, first law is also said to be law of inertia, and the technical meaning of inertia is mass. So first law is classified into three different types: first law of inertia, second law of inertia, third law of inertia, or we can say inertia of rest, inertia of motion, and inertia of, my dear student, direction. Moving forward, see what actually inertia of rest says. Inertia of rest says, if a body is at rest, remains at rest until any external force, cannot apply on it. So this is called inertia of rest, my dear student. If a body is at rest, remains at rest until any external force cannot apply on it. A body remains at rest, cannot comes in motion by its own until any external force cannot applied on it. Moving forward, second is inertia of motion. So if a body is in motion, remains in motion until any external force cannot apply on it. If a body is in motion, remains in motion until any external force cannot apply on it. So this is basically, if a body is in motion without giving any external force, it remains in motion, it cannot stop anywhere, my dear student. Without the presence of external force, if its body is in motion, then it cannot come to rest. Similarly, if the body is at rest, then it cannot automatically come in motion until and unless we cannot apply some external force on it. Then third is inertia of direction. So inertia of direction says, a body cannot changes its direction of motion until and unless we cannot apply any external force on the body. So inertia of direction means a body cannot changes its direction of motion until and unless any external force cannot applied on it. So remember, my dear student, first law is nothing but law of inertia. This law can tell us about the mass, what actually mass is. And we all know about mass. Mass is the physical property of body. It is a scalar quantity. It only depends on magnitude but not direction. Inertia of law of inertia, first law is also called law of inertia. So law of inertia is classified into three different parts. First, inertia of rest, second, inertia of motion, and third, inertia of direction. So if a body is at rest, remains at rest until and unless any external force cannot applied on it. For this law, there is an example. If we have taking a carpet, lots of dust are present on carpet. Apply a hit on carpet with the help of stick, you will see the carpet moves forward because you will apply a force through stick on carpet. But the dust particles which are present on carpet cannot apply any force. So the dust particle remains at rest, carpet moves, dust particle comes down. So this is basically nothing but inertia of rest. Similarly, if we are sitting in a car, or we can say bus, our lower part is connected with bus, the bus is moving. If a driver apply a hard brake on bus, you will move forward. Why? Because your lower part is in motion with respect to bus, but the upper part is at rest. So you'll feel a jerk, my dear student. Moving forward, so this is all about, lots of examples are there related to law of inertia, or we can say first law of motion. These examples, those examples will be studied by you in class 9th, so no need to repeat it. Moving forward, my dear student, write down next topic, that is linear momentum. Linear momentum. Linear momentum. Write down next topic, it is linear momentum. Our topic is linear momentum. Moving forward with new topic called linear momentum. Linear momentum. Write down next heading, it is linear momentum. So what actually linear momentum is? See, linear momentum is basically man-made thing, my dear student. It is not come from natural condition. So linear momentum is defined by linear momentum. First thing about linear momentum is, it is a vector quantity and it is represented by p vector. It is a vector quantity represented by p vector. Now see, if a body of mass m and it is moving with velocity v, a body carry mass m and is moving with velocity v, then its linear momentum is nothing but mv, that is mass into velocity. So what actually linear momentum is? It is the product of mass of the body and velocity of the body with which it is moving. Now see, my dear student, as I tell you, linear momentum is a vector quantity, so the magnitude of linear momentum is mv and its direction is always along the direction of velocity. So if the direction of velocity is in this side, then the direction of linear momentum is also in this side. So I'll write here the direction of linear momentum is always along the direction of velocity. Remember this thing, the direction of linear momentum is always along the direction of velocity. If the direction of velocity is in this side, then the direction of linear momentum is also in this side. So remember, my dear student, linear momentum is a vector quantity. It is the product of mass and velocity. If the particle is at rest, then its linear momentum is 0 because velocity comes to 0. I'll write here, if the body is at rest, then its linear momentum is equal to 0. Its linear momentum is equals to 0. So remember, linear momentum depends on, my dear student, velocity. The direction of linear momentum is always along the direction of velocity. Now see, the SI unit of linear momentum is P, mass into velocity. Mass is kg and velocity is meter per second. So SI unit of linear momentum is meter kg, kg meter per second. Kg meter per second is the SI unit of linear momentum. SI unit of linear momentum. If I am talking about CGS unit, then the CGS unit of linear momentum is P is equals to mass into velocity. So mass is gram and velocity is nothing but centimeter second. So it is gram centimeter per second. This is the CGS unit of linear momentum. So I hope you all understand about linear momentum. Remember, my dear student, if any body having mass m and velocity m and moving with velocity v, then its linear momentum is P is equals to mass into velocity. Linear momentum is a vector quantity. Its direction is always along the direction of velocity. Second thing, very important, linear momentum, remember this thing, my dear student, linear momentum depends on velocity of the quantity. If the body is at rest, then its value of linear momentum is nothing but equal to 0. SI unit of linear momentum is kg meter second inverse. CGS unit of linear momentum is gram centimeter second inverse, because the SI unit of mass is kg, SI unit of velocity is meter per second. CGS unit of mass is gram and CGS units of velocity is centimeter per second. So this is all about linear momentum. Come to our next topic, it is Newton's second law of motion. So second law basically tell us about what actually force is. So write down Newton's second law of motion. My dear student, write down next topic. It is Newton's second law of motion. Write down next topic. Newton's second law of motion. 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 See, my dear student, second law can tell us about what actually force is. So I'll write here second law of motion. Second law tell us about what actually force is. So write down second law, write down second law, Newton's second law tell us about force. Second law of motion tell us about the force, what actually force is. Now see, my dear student, what second law says. Second law says the applied force is equal to rate of change of momentum. The applied force is equal to rate of change of momentum with respect to time. So this statement says applied force is directly proportional to rate of change of momentum with respect to time, that is dp vector by dt. Force, that is applied force, is directly proportional to rate of change of momentum with respect to time. This is what actually second law of motion is, or we can say Newton's second law of motion. The applied force is equal to rate of change of momentum with respect to time. F vector is proportional to dp vector by dt. Now see, my dear student, if a body carries some mass m and moving with velocity v, then its momentum, we know that it is mass into velocity. So I'll put the value of momentum here. So what we'll get? We'll get F vector is proportional to d over dt m and v vector. Now see, my dear student, proportionality, if we wish to remove the proportionality and put it equal sign, then constant must be introduced. Here the value of constant is 1, so we cannot able to write it. So we'll write here F vector is equals to d over dt mass and velocity. Moving forward, my dear student, see, this is our first function and velocity is our second function. We have to differentiate this, as we know the product rule of differentiation. It is product rule of differentiation by product rule of differentiation So what product rule says, my dear student? Product rule says that first function as it is differentiation of second function plus second function as it is differentiation of, my dear student, first function. So first function is mass and second function is velocity. So first function as it is differentiation of second function plus second function as it is differentiation of first function. This is the value of actual force. Remember, my dear student, this is nothing but actual force. Very important relation, my dear student. F vector is equals to m dv vector by dt plus v dm by dt, my dear student. This is the actual force which is acting on any particle. I'll write here actual force acting on particle. This is nothing but actual force acting on particle. Now see, the mass which is R in course is always a constant mass. Remember, my dear student, masses are of two types. I'll write here masses is of two types. One is your constant mass and second is your variable mass. So two different types of masses are there. Variable mass means the mass which is changing, like let's suppose you are fill petrol on your bike. Let's suppose the volume of petrol is 10 liter. In that case, when petrol is full in your tank, in your bike tank, that time mass, and after driving 100 kilometer the fuel burns, then the mass will changes. So that type of mass is called variable mass. The mass which is changing with respect to time is called variable mass, and the mass which cannot changes with time is called constant mass. So in our syllabus, my dear student, we always deal with constant mass. So I'll write this is the actual force. This is the actual force which is acting on any body. It is m dv by dt plus v dm by dt. Now moving forward, if mass is constant, as we have to deal with constant masses, my dear student, so if mass is constant, then we know that the differentiation of constant is 0. So I'll write here if mass is constant, I'll write here if mass is constant. So m is constant now. So the value of force is m dv by dt plus v dm by dt. Now see, my dear student, mass is constant. So for constant, differentiation must be equal to 0. So this becomes equals to 0. So F is equals to m dv by dt plus v, mass is constant, hence its differentiation is 0. So this becomes equals to 0. So F is equals to m dv by dt. Now see, rate of change of velocity with respect to time is nothing but acceleration. So this terms becomes equals to a vector. So F vector is equals to mass into acceleration, and remember this is nothing but net force acting on body, and this a is net acceleration of the body. So remember, my dear student, second law of motion says rate of change of momentum with respect to time. The applied force is directly proportional to rate of change of momentum with respect to time, and the actual force which is acting on any body is m dv by dt plus v dm by dt. If mass is constant, then we know that the differentiation of constant is 0. So the force, the value of force becomes F vector is equals to m into a. Remember, this F vector is net force acting on body, and this a is net acceleration which is achieved by body due to the force. Moving forward, my dear student, let's start Newton's third law of motion. So write down heading. I hope you all are understanding. These are very easy topics, my dear student. Kinematics and mechanics itself in physics is very easy. You have to focus, you have to learn again and again, you have to practice the question, then you will achieve the target what you want. So write down next topic. It is Newton's third law of motion. This is the universal law which everyone knows about this law. Everyone knows about this law. So write down Newton's third law of motion. Newton's third law of motion. So what is actually third law of motion? Third law of motion is to every action there is equal and opposite reaction, my dear student. Write down Newton's third law of motion. Newton's third law of motion. Newton's third law of motion. Write down Newton's third law of motion. So third law says to every action there is equal and opposite reaction, my dear students. So write down to every action there is equal and opposite reaction. See, here action and reaction is nothing but force. This law says if you are applying force on any body, then that body also apply force on you, equal in magnitude and opposite in direction. So if you are acting action, then body will be get back to you and it reacts. It reacts. So action and reaction are forces which is acting on two different bodies. You have to remember this thing, my dear student. Actually, action and reaction are forces. Action and reaction, my dear student, is forces, and remember this thing, these forces are acting on two different bodies. Remember this thing, action and reaction are forces, and these forces are acting not in same body. These forces, action and reaction, must be, in two different bodies. So we'll say if I am acting a force on any body, let's suppose we have one first particle and a second particle. We have, let's suppose, two particles. Let's suppose first will apply force on 2 due to 1, then 2 also apply force on 1, that is force on 1 due to 2. So we'll say force on 1 due to 2 must be equal to force on 2 due to 1, along with negative sign. This negative sign shows that both the forces are equal in magnitude but their directions are opposite. So remember, my dear student, this is what actually Newton's third law of motion is. Third law of motion says to every action there is equal and opposite reaction. Action and reaction is nothing but force. If you will apply force on any body, then that body also apply force on you by equal in magnitude and opposite in direction. So remember, action and reaction, these are nothing but forces, and these forces are acting on two different bodies. So I hope you all understand what actually equilibrium of forces is, what are the Newton's laws of motion, and application of equilibrium of forces. So my dear student, thank you so much for this class. We'll meet on next class with a new topic, that is application of Newton's laws of motion. Until unless, take care, study hard, study safe, stay home, make your proper notes, try to revise each and every formula every day, my dear students, so that your concept will be builded. Thank you so much. Take care.